Hi guys, Matt from Willow Tree Engineering here again. I'm just going to walk through this project, which is going to be the subject of our next series. But first up, I'm just going to show you what's been done, show off a few of the parts because some of them are quite rather special. But if you haven't already worked it out, it's a 5-inch gauge, inch and an 1/8 scale, New South Wales Government Railways 57 class. The first part to show off will probably be the front buffer beam. This one's a little bit unusual and there's a solid casting. It's been cast in 4140 grade steel and it's been done with a lost wax process. So it's been done by a firm in Sydney. They've 3D printed it in wax and then they've cast it into the steel. Some of the advantages of this process is that we have hollow ends in the end of the beam. It also, because we're doing this commercially, we have to look at the cost associated with things. The cost of machining it out of a solid piece of steel with all the extra details and even just the fixing, which I'll show you in a minute, would have been more than the cost of getting this casting made. So while we're also on this casting, you'll see we've got our coupling hook and coupling pocket. They're both done the same, so they're all cast in 4140 as well. A few other bits of detail. We've got our shunter steps. We do have the handle there as well, the grab rail. It's just in a safe spot at the moment, so it doesn't get knocked off or damaged. We've also got part of our valve gear for our 3rd cylinder. This is all lost wax cast as well. Which makes life really easy when you're doing this type of project. Another reason for the lost wax cast front buffer beam can be seen in this shot. We were asked to do bolted together frames for the locomotive, and the only way we could achieve it and still maintain the prototypical look from the outside of the locomotive was to use these bolts, use this location here and bolt from the inside out. So trying to drill those holes when there's 2 bars next to each other would be quite difficult in getting them accurate. So these are able to be printed and cast into the unit and the bolts just go straight in. I don't have them in at the moment because I need to take them off so I can drill the bolts that hold this bracket here on. Also in this shot you can see the hardened steel pins for the pivots in the valve gear. Right, I've had to switch to handheld for this bit, so sorry if it's a little shaky. But this is just showing that the crank axle and the stepped axle. So the crank axle at the back here has been all keyed in position and the quartering has been set up using the jig I described in the AME probably a couple of years ago now. And it also set at funny angles. They're not set at 120, 120 and 120. They're actually set at 118, 122 and 120. So I'm not 100% certain why, but it has to do with the slope of the cylinder at the front. And in front of that we have the stepped axle, and the step in this axle is to clear the connecting rod as it spins around on the background. Of course the clearances involved would impact the axle without that step. Now that was a fun job. That was all machined out of a bit of 2-inch round 1045 rod shaft. While we were set up to machine the bronze bearings for the coupling rods, I also punched out a few other bronze components. So on the far left here we have the split bearing for the centre connecting rod for the big end. We've got the main piston glands. We've got the valve glands, and these 3 here, because our covers, which you'll see in a minute, are actually cast steel, I didn't like the idea of a stainless steel piston rod working on the steel covers, so I machined a bronze bearing just to create a little bit of separation. And on the right hand side we've got the outer big end bearings as well. As we mentioned before, we machined the bearings for the coupling rods. And we've also now got them fully machined and fitted to the locomotive. And I'm quite pleased. It's stiff, but there's no tight spots, which is nice. Because this locomotive is also going to be running on some fairly tight curves, we've had to allow a bit more than normal movement on the back couple of bearings, just to let the wheels go around the corners. Also, I've currently got the valve gear drawings away at someone who's very good at just double checking the measurements are right. So he's going to punch all those numbers through a simulator, and once that's done, we can then set this in position and drill for a hardened pin down through there to hold that in place. The rear bogie has also been machined. The axle box is fitted, wheel sets in. The next step for me is to make the rear drag beam. So once that's done, I can then mount the rear of the bogie on this casting, which I'll show you in a minute. I'll also get a close-up of the axle boxes and show you that. So these are the axle boxes for the rear pony truck. And again, they're a lost wax steel casting. And I'm glad I've done this because I've need to put some studs in there that on the prototype held that cover on. We've also got a bronze slipper in the sides that the bearing works on. So I didn't like the idea of it running on the aluminium. I believe that would wear that out fairly quickly. And I don't like aluminium as any sort of bearing surface. These are another casting we've had made here at Willow Tree Engineering. These control the height of the back of the rear pony truck, and the idea is that as it moves, it maintains a constant height as it just rocks back and forth. The really neat thing about these is the level of detail we've managed to achieve. So if you look closely here, on the prototype, this was the symbol of the manufacturing firm. We couldn't reproduce the detail, unfortunately. But on the prototype we've got a casting number, a date, and then the Made in the USA stamp all cast into the side of that unit, which is rather a neat thing to achieve. The lost wax castings on this locomotive are really going to set it out as different. All of these are cast in steel using lost wax. These ones our customer provided to us, ready to go. We've got our cylinder covers, so they're all been machined, ready to go. Behind that we've got our crossheads with detail like your oil box on the side, cast in, so they won't be too far away before they get machined. We've got our valve guide at the back, again with our cast slides there, guides, with a little oil well cast on the top. We've got our girder for our expansion link. The bearings are the same, and I think these ones are for the way shaft. Right, this next casting is a rather impressive one. This is our cylinder block. It's a little bit unprototypical in that it's all one piece. The full size ones are joined down here and they actually bolt together. This one's come to us partially machined. It's a really nice job on the bores. We just need to adjust the lengths to get them right, and if that's still a rough cast finish there, drill our steam inlets, drain cocks, and work out how we're going to get this to mount to the frames, which once the rear drag beam's done, that'll be our next priority.